Good morning. Welcome to our talk, Pwned in Translation, from Subtitles to Remote Code Execution. We're Omer and Omri, security researchers at Checkpoint. And what we're going to present today is a new concept, a new attack vector. We call it Subtitles drive-by attack. And it's important to remember that this is not about the vulnerabilities, even though we have plenty of those. This is the notion that subtitles are considered dangerous. Okay, so let's back up a little bit. This is how we used to watch movies at the local cinema. But as technology evolved, the internet got faster and we got lazier, movies entered our living rooms. It could be a laptop, a smart TV, a Raspberry Pi, or an actual media center. The streaming options are endless. Designed with ease of use in mind, they take care of everything for us. They pull all the metadata for us, the trailers, the thumbnails, plot info, and subtitles. Yeah, it's a thing. These are the statistics of daily downloads from one of the main repositories, Open Subtitles. Ranging from 7 to 10 million daily downloads, it's definitely a thing. And obviously, subtitles are used for non-native English speakers like ourselves, but not only. And to convey the necessity of subtitles, we'll use the power of memes. They're used when watching foreign films or TV shows, such as anime or a pretentious French film. They're used for convenience in case there are any sort of sound limitations. And they're used in Guy Ritchie's movies. Sometimes they also provide critical notes for the hearing impaired, as you can see. But they usually have a lot more than just text display. Let's explore the subtitles landscape. We all know SRT, subrip text. It supports very basic set of HTML tags such as bold, italic, underline, and font. There's also the sub format, stands for subviewer. It supports basic formatting like color and fonts. But sometimes sub actually stands for MP sub, that supports none of the above. And at different occasions, sub can also stand for micro DVD subtitles. These sub supports formatting, color schemes, font configuration, subtitles location, and different character sets. Another common format is the substation alpha. It's a bit more sophisticated. It supports predefined style names, fonts, complex color palettes, outlines, shadows, alignment, margins, alpha level, and encoding. But it gets even more impressive as we move on to advanced substation alpha. ASS contains all the functionality of SSA with some interesting additions. The ASS format supports scaling, angle shifting, binary image embedding, binary font embedding, drawing. Here we actually draw a small dinosaur as part of the subtitles. And the specification even mentions system commands. It allows executing a specified program as background task. And we truly hope no one ever implemented this bizarre feature. So back to our subtitles. There are actually shitload of subtitle formats. All in all, during our research, we encountered more than 25 subtitle formats. Some are binary, some are textual, none are well documented. And we asked ourselves, can the unregulated nature of this subtitle madness be exploited? So our first target was the most notorious streaming platform we know, Popcorn Time. The multi-platform Netflix for pirates integrated a deadly combination of a BitTorrent client, a video player, and endless scraping capabilities. They're all packed under a very friendly graphical user interface. Even my mother uses it, which is a key lead in every research we conduct. The beautiful WebKit is packed with movie information and metadata. It presents trailers, plot summaries, cast information, cover photos, IMDb ratings, and much more. But the way it does it so elegantly beautiful is using a platform that supports web technologies. Technologies as HTML5, CSS3, and JavaScript built on top of a Node.js engine. The two main frameworks that allow such beauty are NWJS and Electron. Both are multi-platform, utilizing Chromium, and supports external plugins. Okay, so we know they look good, but are they vulnerable to anything? These underlying technologies are very interesting from an attacker's perspective, especially because what might be considered as a weak vulnerability, at least in bug bounty programs such as XSS, can actually result in remote code execution. Because Node.js is essentially a JavaScript engine with server-side capabilities. All you need to do in Node.js in order to pop a calc is use this code. It imports the child process library and uses its exec function with calc as the argument. We'll talk about this in a minute, but back to popcorn time. To make life even easier, subtitles are being fetched automatically for both the viewer convenience and the attackers. And the question remains, can this behavior be exploited? Behind the scenes, Popcorn Time uses Open Subtitles as their sole subtitle repository. With over 4 million entries and a very convenient API, it is an extremely popular repository. This API does not only allow for easy search and download of subtitles, it also has a recommendation algorithm to help you find the right file for you. We'll dive deeper into that process a bit later, as it turns out to be a key step in our strive for world domination. So, gaining some knowledge about Popcorn Time, let's see how the subtitles make their way from download to the screen. Our journey begins as soon as the user starts playing a movie. Popcorn Time downloads the subtitle and converts whatever subtitle format it gets to an SRT timecode. After the conversion, it is passed to the update display function. This function will create an HTML span containing the subtitle text. Now, since the SRT format supports HTML tags, and this is a WebKit, they didn't need to make any implementation of HTML support for the subtitles. It is obviously built with HTML to its core. But perhaps we can write other things than HTML, like JavaScript, unsanitized JavaScript within a Node WebKit application. Let's try this simple one. This is how a standard SRT file looks like. As we already know, it supports HTML tags. But what if we try to load an image that doesn't exist and provide it with the onError attribute? XSS 101, we know the onError attribute can run JavaScript. So, brace yourself. Yeah, we got our first vulnerability for the day. We managed to make subtitles pop a message box inside Popcorn Time. But that's not good enough. Let's try something a bit more advanced. What if instead of the alert, we write a code to clean things up, remove the revealing icon of the broken image, and append our malicious payload to the page, which would dynamically create a script loaded from a remote host, our host. And needless to say, just as we showed earlier, Evil.js will utilize the Node.js capabilities to run a process. Let's see how it works. The user opens subtitles, Popcorn Time, it chooses his favorite movie. loads the subtitles. And what happens at this point is that the malicious subtitles are loaded. As you can see on the attacker side, it now has a VNC over the victim's computer. Okay. So we know how to create malicious subtitles for popcorn time. That's cool, but how would the user get those subtitles? Let's talk a little about the subtitle supply chain. With an average of 8 million daily downloads, Open Subtitle is the world's largest online community for subtitles. The extensive API is widely integrated into many other video players. Among the basic functions you would expect to find in such API, such as download and upload of subtitles, there's the smart search capabilities. The smart search is essentially a chained function requesting all relevant subtitles from the server, sort and rank them, and return the best matching subtitle for your movie and release. Let's see how it works. Now, looking at the request of the smart search, we can see the only argument passed is the IMDb ID, along with the required language, in this case, all languages. While the response contains all matching subtitles to the IMDb ID. So obviously, Popcorn Time automatically loads the subtitles with the highest rank. But what determines the rank? Skimming through the documentation, we bumped into this ranking scheme. We can see that the score is based on 5 criteria: movie hash, tag, IMDb ID, FPS, and something called others. Also, extra points are credited for being an admin or a trusted user. But since the only argument sent by Popcorn Time is the IMDb ID, if we would have wanted our malicious subtitle to be chosen by the API, the maximum points we could have get is 5, us being anonymous users. So a bit discouraged by the documentation and scores seen in all other popular movies, which were higher than 5, we turned to the source code of Open Subtitles, where we learned a valuable lesson. If you truly want to break something, looking at the documentation is not the way to go, because the source code revealed an undocumented behavior. The match tags function is called either way, but what is match tags? The match tags function will break the file name of the movie and subtitled to tags. A tag is basically an isolated word or a number found in the file name, usually separated by dots and dashes. Then a short loop checks how many share tags does the subtitle file name and the movie file name has in common. After that, a weird formula is taking place. The amount of share tags is then divided by the number of movie tags and multiplied by a max score of 7, which is the max score that can be assigned in case of full compatibility between the two file names. Let's see a demonstration of this function's behavior. Let's assume this is the movie file name streamed by Popcorn Time, which is easily checked using a sniffer. And this is the name of a candidate subtitle file name. The code first splits the file name into tags. It then splits the subtitle file name. The match tags function then checks how many shared tags they have, 3 in this case. The API then goes to its formula, which is share tags, 3, as we just saw, divided by tags in the movie file name, 8, we see that on the left, multiplied by the max score, which is a constant number of 7. This gives us the final score of 2. Well, this behavior makes it trivial to achieve full compatibility. All we have to do is name our malicious subtitle identically to the movie file name. In this case, we get full compatibility plus the IMDb ID 5 points we already had, and we get 12 points. But wait, there's more. These are the recommended subtitles for some of the most popular content available online. Deadpool, Frozen, Inception, Snowden, and Westworld Season 1, Episode 1. These graphs show the score for the 7 most popular languages in the world, displaying their average and highest score. Scanning automatically through a bunch of popular subtitles, we noticed that the highest score a subtitle got was 14, while the average is around 10. At this point, we've shown that we can consistently achieve a solid score of 12, higher than the average, but still we were unsatisfied. As you recall, extra points are credited for being a ranked user. So, crawling Open Subtitles website, we found this table. Apparently, all it takes to become a gold member and earn extra 3 points is 101 uploads. So we sign up to Open Subtitles, and 4 minutes later and 40 lines of Python, we were golden. So we wrote a small script that gets the score of all subtitles available for a given movie. As you can see, our subtitles has the highest score of 15. What this basically means that given any movie, we can force your player to load our crafted malicious subtitles and exploit your machine. Okay, so let's see what else we can do with it. Omer will take it.
Hi. So Kodi, which is formerly known as XBMC, is an award-winning open-source cross-platform media player, which is available in all major platforms. It is available in 72 languages and is used by over 40 million people. It is probably the most common media center software around. And Kodi is also a popular combination with Raspberry Pis and Smart TV, making it kind of interesting from an attacker's perspective. So this is the screen displayed when you want to download subtitles using Kodi. This is the request being sent by Kodi to the subtitle repository. We recognize it as we're already familiar with the Open Subtitles API structure. And this is the code that is actually fetching the subtitles. First, the search subtitles function is called, and the response is saved into a variable called search data. Then a for loop will iterate over these results, extracting the information from them and formats them into a string called URL. Then each of the created URLs are sent to the add directory item function, which in turn results in this screen. And now the user can select his desired subtitles. Let's focus on that URL string for a moment. Since Open Subtitle is, well, open, an attacker has control over the file name parameter, received under the value of sub-file name. And here we see how each of the 4 keys in item data are formatted into that URL string. Given the fact that an attacker completely controls the file name, what can he do with it? Now, usually the file name will be something like subtitle file name.srt. But what if afterwards we append the ampersand sign? And then we add something like this. This would effectively overwrite the original link and ID parameters, which we originally didn't have any control over, simply because this is a string and it is being parsed by a basic split function. But how does this help us? Once the user chooses his subtitles, the download function would be called. The arguments to that download function are derived from that URL, and these are the arguments we can now control, the ID and the link. So how does this function behave? First, it uses Open Subtitles API to try and download the subtitle based on the ID given to it. But the interesting part is what happens when it fails, if the ID does not exist. Then the not result branch is taken, which downloads a zip file from the link given to it. So by changing this ID to something that doesn't exist, such as -123, and overwriting that link, to point to a zip stored on our servers, we force Cody to download the remote zip file. And after this download, the zip file will be sent to the XBMC extract function. Now, instead of using a standard library for zip extraction, Cody decided to implement their own, which, as we all know, is usually a great idea, right? So downloading an arbitrary zip archive from the internet is definitely careless, but chaining this behavior with another vulnerability we found in Cody's built-in extraction made it lethal. Let's see. What the Cody built-in extract archive function does is building a file path based on the folder names inside the zip. But what Cody neglected to handle are folder names that contains 2 dots. So that's right, we have directory traversal here. So all we have to do is create a zip that contains dots as folder names, and then we can make the extraction create a Python script instead of the add-on itself, which will be immediately called again, right? Thus executing our code. And this is our second vulnerability for today. And let's see how that looks on Cody. This is Omri's dogs. Chooses a film. Now he opens the subtitles menu, turns to the API, get all the subtitles back. All top 3 results are malicious subtitles. Now dramatic zoom out, we look at the attacker's computer. And we get a VNC again, and full control over the victim's computer. Okay, on to the next victim. Now, popcorn time definitely marked the rise of streaming apps, but being temporarily shut down by the MPAA, it left users looking for alternatives. And Strem.io offered just that. Like popcorn time, it is designed with ease of use in mind and has quite similar user interface. By the way, this is also the platform that both of us use back home when we're pirating, but don't tell anyone. So we thought it would be fun to give it a shot. Interestingly enough, Strem.io shares a few characteristics with popcorn time under the hood. Most importantly for us, it is also a WebKit-based application, and it also uses OpenSubtitle as a subtitle provider. So obviously we tried the same trick that we used on popcorn time. You can actually see the broken image icon at the bottom, but no message box was popped, so that didn't work. Because apparently, our JavaScript has been sanitized, and we needed to dig a little deeper. Strem.io code is archived as an ASR file, which is a simple tar-like format that concatenates all files together, just without the compression. So we used a Node.js library to extract it, and we got all the necessary files we needed in order to inspect the code. And extracting the code and prettifying it, we realized that any text added to the screen is passed through Angular Sanitize. And this Sanitize service will parse an HTML and only allow for safe and whitelisted markup and attributes to survive, thus sterilizing the string so it contains no scripting expression or dangerous attributes. So having to use only static HTML really limited our options, so this called for kind of a creative solution. If you've ever used Strem.io, which is great by the way, you must be familiar with their Support Us pop-up banner. Now, we know that we can use HTML tags, right? So what if we present the Support Us image to the user using the image tag, but surround it with an href? This way, there's no JavaScript to be sanitized, and once the user would click the image in order to close it, he will be redirected once again to our malicious JavaScript. Let's see that. And closes the banner. And calc. Yeah. So, realizing the disastrous potential of subtitle as an attack vector, we moved on. And I'm pretty sure that there is no need to introduce our next target. With over 180 million users, VLC is one of the most common media players out there. This open source, portable, cross-platform media framework is available for almost any platform imaginable. By the way, we are not completely sure what Tizen is, but I think my refrigerator at home runs it, so it might be dangerous. VLC is in fact a complete multimedia framework, just like DirectShow or GStreamer, where you can load and plug in many modules dynamically depending on the necessity. And the core framework is just used to do the wiring and the media processing. So from inputs like files and network streams to outputs, audio, video, on-screen or on a network, it uses modules to do most of the work at every stage, like various demuxers, decoders, or filters. Now, being described even by its own authors as very popular but quite large and complex piece of software, we are confident that subtitles-related vulnerabilities do exist. So, textual subtitles are parsed by VLC in its demuxer called subtitles.c. And these are all the supported formats and the respective parsing function. Yes, that's quite a lot. And the demuxer's only job is to parse the different timing conventions of each format and send every subtitle to its decoder. Now, other than SSA and ASS that are decoded by a dedicated library called libass, all other formats are decoded by VLC's own decoder, subsdec. Inevitably, things are about to go terribly wrong. So, subsdec will take every subtitle, SRT in our example, and parses its text field. It then creates two versions of it. The first is a plain text version with all tags, attributes, and styling stripped off. This will be used in case later rendering will fail. The second, more feature-rich version is referred to as the HTML subtitle. HTML subtitles will contain all the fancy styling attributes, such as fonts, alignments, etc. And after being decoded, subtitles are sent to their final stage of rendering. Now, going over the VLC subtitle-related code, we immediately noticed a lot of parsing is being done using raw pointers instead of built-in string function. And this is generally a bad idea. So let's see an example of it. Again, this is how a basic SRT subtitle looks like. And this code uses the PSD subtitle variable to parse the subtitle 1 byte at a time. In this case, the code just identified the HTML font tag. It then moved on to consume its attributes, the face attributes in this case. The decoder will continue reading from the buffer until a closing bracket is met. What this means is that in case a closing bracket is missing, then the parser will just keep on reading, resulting in an out-of-bound read vulnerability. And while we audited the code manually, we also started fuzzing VLC for subtitles-related vulnerability. And obviously, our weapon of choice was the brilliant AFL. This security-oriented fuzzer employs compile-time instrumentation and genetic algorithms to discover new internal states and trigger edge cases in the targeted binary. So getting the fuzz command right was just a bit tricky. We created a corpus, and we also created a dictionary, but our main obstacle was the fact that our fuzzing server had no GUI. So we overcame this challenge by using the transcode functionality. This option will make VLC convert any movie from one codec to another, attaching the subtitles, but displaying nothing. So this was perfect for us. So to the corpus. The corpus is a set of initial test cases comprising of valid files that represent the protocol or functionality being fuzzed. And we plan to start with SRT and ASS, simply as these were the formats that we researched first. So for our corpus, we cherry-picked various files that incorporated some of the more exotic features that we discussed earlier. And this is the basic time convention of an SRT subtitle. We intended on adding more formats to the corpus as we go along, but the amazing thing is we didn't have to, because AFL just blindly built valid subtitles files of different formats with zero knowledge. In this case, he created the JSS format all by itself. And this is a demonstration of one of AFL's greatest strengths, which is assembly-level instrumentation. Because the odds of a traditional fuzzer that randomly flip bits to take one timing convention of SRT and turns it into JSS are extremely low. However, through this assembly-level instrumentation, AFL notices how minor mutations are triggering slightly different code path, and it uses those as a seed for further fuzzing rounds. So, great job, AFL. And it didn't take it too long to lock down on a vulnerable function called ParseJSS. Now, JSS stands for JCO subscript files. And this is a really flexible format. It and has some really interesting functionalities. It relies heavily on something called directives. And a directive is a series character codes strung together. And they determine subtitles' position, font, color, and so forth. And they can come in two forms: as a global directive that will affect all subtitles below it in the text file, or as an inline directive affecting only the current line. Now, these are some of the more common directives in JSS. T, which stands for timer, is used to set the time resolution, 100 units a second in this case. S, that stands for shift, will cause all events to occur 20 time units sooner than usual. F will set font number 3 because you can predefine up to 10 fonts to JCO sub font 18, which is a monocolor font that is available in JSS. And for an inline directive, CP2 will display the following text using color palette number 2, which can be also predefined. So yes, it is very weird, and no, VLC does not do a great job in parsing those. And looking at the basic ParseJSS function, we can see that VLC iterates over the lines in a while loop, again 1 byte at a time. And it passes the time codes and a handful of supported directives and the text itself. And the crash found by AFL was due to an out-of-bound read while trying to skip unsupported directives. Here and throughout, PSZ text is a pointer to a null-terminated string allocated on the heap. And the code assumes a directive is always followed by a space. Therefore, it will look for that space to indicate the end of a directive. In case the directive is written without any following spaces, this while loop would just skip the null byte terminator and overrun the buffer. And this got our attention to the ParseJSS function, and we soon manually found another 2 out-of-bound read issues in the parsing of the directives that actually were supported. Moving on with the JSS format, we stumbled upon the color and font directives. And as you can see, this code includes a double increment to skip from the directive over the space and right to the argument. But in case a directive didn't contain any argument to follow it, meaning it ended with a null termination, this double increment would just skip the null terminator. But let's see how this code is combined within the bigger picture. So the entire chunk of code is within a while loop, and here's our double increment. And skipping the null byte, we remain in that while loop, copying from PSZ text to PSZ text 2. However, PSZ text 2 is only the length of PSZ text plus 1. So while we read out of buffer at one point, we also write out of buffer at another. And this sixth vulnerability, heap-based overflow, actually allowed us to ultimately execute arbitrary code. At another case, my personal favorite, you can see that when the parsing loop reaches a null terminator in a specific case, it intentionally decides to skip it, making this number 7. Okay, let's talk about exploitation for a second. These bugs are not trivial to exploit. However, it is interesting to note that the main binary of VLC is not ASLR or Pi, like it's called in Linux. And by design, the main binary is just do the wiring between libVLC and the plugins, but it still offers some quite useful gadgets. For example, this gadget that will find the symbol of whatever string is in RSI and then call it with RBX as an argument, which is a pretty useful gadget, right? So for a quick POC, we had one of the team members, Yanai Livne, who is also half a Linux from his father's side, to develop an exploit for this vulnerability, for the moment ignoring ASLR. And this is the demo. And calc. Okay. Let's sum up this research. We discussed the complete madness that is the subtitle landscape. We saw we had over 25 subtitle formats, none of them well documented, without any dedicated libraries, and zero standardization between players. We were able to gain full remote code execution on 4 major platforms. Now, please note that these were the only platforms that we looked at, and this means that other platforms out there are probably vulnerable to subtitle drive-by attack. We are also able to manipulate the subtitle repository ranking scheme, thus taking control completely over the subtitle supply chain. And this means that what we just presented is a new malware delivery system that is completely transparent and requires no user interaction, which in our case included over 220 million potential victims. And the notion of attackers being able to upload malicious subtitles to a major repository and forcing different players to download them should now be taken into account as a new valid attack vector and prepare the security vendors to mitigate it. And now the moment you've all been waiting for. Omri and myself, we made a little bonus for you. We curated our favorite calc popping scenes into a beautiful compilation. And actually on the first draft of this talk, this bonus was titled 2 Girls, 1 Calc, but that almost got us both fired, so we had to tone it down a little bit. And here it is. Enjoy.
People sometimes make mistakes.
Yes, they do.
How can he talk?
It's not a real voice. This box just interprets signals from the computer and turns them into sound.
Shall we play a game?
Oh.
I think I missed him.
Yeah, weird, isn't it?
What is it?
Is that what I think it is?
Mm-hmm. Damn it, what is it?
You want to play games? Okay. I'll play with you. Come on. Okay. Do you want to play with? Okay. Say hello to my little friend. You want to play with? Okay. Go. Okay. You love that? Huh? You want more?
And that's just a sample of the exciting exploits ahead in our first feature motion picture.
Holy memoranda, folks. Make a note not to miss it.
Good thinking, Robin.
Thank you.
Thank you, guys.
Question?
Thank you. Any questions?
Would it be better just to turn off subtitles?
Depends if you need them.
Shut down the internet.
Good idea.
Who knows?
If a calculator pops up.
It won't be a calculator.
Nope.
No, these are the only platforms that we looked at, and we were pretty successful with all of them. So please do. All right.
That shouldn't be an issue because it's part of the movie. So it's not being parsed by the player.
Work on video games?
Haven't tested it. Does video games has subtitles?
Well, they have a lot of interaction. I don't know. I don't play video games.
Yeah. With the Kodi box itself? No, we tested it on the software itself. The operating system shouldn't really make a difference. Yeah. Couldn't tell you. Yeah, this is just the ones we looked at. Safe to assume it has vulnerabilities on other platforms as well. Okay. Thank you very much.
Thank you.